All right, here we go, guys. Intro to unit circle. Did I already get you a copy, miss? Give her that extra. All right, let's start with the basics. A circle. All right, guys, let's focus. Remembering the section on circles from geometry, algebra 2. We have an equation. I don't know if you guys remember equations of circles, but if you don't, I'm going to hook you guys up. The equation of a circle centered at the origin is written as x minus x naught over rx, close it squared, plus y minus y naught over ry, close it squared, equals 1. Does that look familiar to you guys? If rx equals ry, you have a circle. Maybe you saw it this way. They use the letter, let's see, x naught and y naught is the center. But maybe you saw it with h and k, so maybe you saw it like this. X minus h, close it squared, plus y minus k, close it squared, equals r squared. It's the same. Well, kind of the same. Assuming that if it's a circle, well then yeah, I have no choice. That has to be r squared. But it's pretty much the same. So we're centered at the origin and the radius is 1 because it's called a unit circle, because 1 unit. So then it's gonna be like this: x squared plus y squared equals 1. So that's the equation of a unit circle. Nothing crazy, pretty straightforward, right? Okay. We're good? Yeah, well, let's pause. We should have like Demi Lovato sing to us during every pausing moments. You know? All right. We have some special angles on this unit circle. We have some special, oh, by the way, what does Winters call this? Does he call it initial? Does he call it x naught? Yeah, it's x naught. You can also call it initial. Like when you do this, xf minus xi, position final minus position initial. No? Okay. All right. It's not or initial. It's the same. All right. The unit circle. Here we go. I'm going to draw a grid. I'm going to try to draw it x and y. And I'm going to try and draw a circle. It kind of looks more elliptical than circle-ish, if that's a word. But, we'll go with it. We have special angles. So from the x-axis, the first angle is going to be at 30 degrees. That's what's 30 degrees. The next angle is going to be at 45 degrees. I'm going to choose 3 different colors. This is what's 45 degrees. The next one is going to be at 60 degrees. And then, of course, you have your axis. That has to be 90 degrees. And you're going to You're going to continue with the same pattern. So it's 30 degrees away from axis, and then in between these are 15-degree increments. That's a 15-degree increment there. That's a 15-degree increment there. And then 30 degrees away from the axis. So the next angle, I'm just going to do all of them the same color now. The next angle has to be 120. 30 degrees away from 90, right? The next angle after 120, what do you think is going to be? Not everyone at the same time? Yeah, 135. Just add 15. The next angle after 135 is going to be 150. And then you're in the x-axis, but the negative one, so that's 180. And sorry that my circle is not super awesome. Remember, I got a D in art. I don't know if I told you guys. That's a true story. I don't like to talk about it because it brings back nightmares. That's 210. Now, the honest truth is I don't know how I got a D in art. But I did. I got a D in art. It's the very first line on my transcript for my university. You think I'm joking, but I'm being super serious. It's the only D I ever gotten. Yeah, that's 225. I just added 15 degrees to the 210. And then add another 15 degrees to that 225. 240. That's 240. And then the y-axis and the negative y-axis is going to be 270, but we already knew that. And then take a guess. What do you think this is? 300? Are you guys almost scared? Okay, I'll wait. I'm just doing special angles, guys. They're 30 degrees away from the axis, and then they go by 15 degree increments, and then 30 degrees away from all axes. So 315 is the next one. And then go another 15, 330, and of course you're 30 degrees away from the x-axis, so there it is. And then once you do a whole revolution, 360. Oh, good thing they turned it off. Yeah, we're not going to go outside because it's too hot. We'll just, I don't know. All right. How do we feel? No, I think we're good because I just saw Arzimendi pass by. So I think we're in the clear. That means, yeah, let's just continue with math life. Okay. Are we in the clear with this so far? Okay. All right. Turn the page. No. I don't think I'm going fast. I just drew some lines. No, you don't. I mean, you don't have to look. You can just know the patterns. Go by 15. No, I got you, miss. You're a perfectionist. All right, here we go, guys. So 30, 60, 90, 45, 45, 90 triangles. So on the 30, 60, 90, you have n square root of 3, and 2n. And maybe you're getting tired of this over because we've been doing this for a while. And on the 45, 45, 90, it's n, and n square root of 2. Remember in a unit circle that the radius is 1 because it's 1 unit. So if we know that the radius is 1 unit, we can plug in the coordinates that we already know because the radius is 1. So that means this coordinate way over here is 1, 0. And this coordinate up here is 0, 1. Yay or nay? Yay, right? All right, next, what do we know? Well, we know, let's see, that's 0 degrees here. Then this first one's at 30 degrees. And then the second one's at 45. Then this one's at 60. And then that's 90. And this one down here is if you do one complete revolution, so 360. Are we still okay? All right. Now, I don't know if you guys recognize, but here's a 30, 60, 90 triangle. So this one right here, look at that triangle right there. That's a 30, 60, 90 triangle, guys, where this is my 30 degree angle. So I'm going to see if I can copy it. I'm going to see if I can. Let's see. Will it let me? Duplicate. I don't think it caught the top line. Oh, that's lame. That's fine. It's that same triangle. Oh. There. It's that same triangle, guys. See? Right triangle. So here's what I'm going to do. The radius is 1. So I'm going to put a 1 there because that's still my radius. See? I need to figure out my horizontal displacement and my vertical displacement. This is a 30, 60, 90 triangle. So I'm going to figure out my horizontal displacement and vertical displacement using my trig ratios. I know n squared root of 3, and 2n. That hypotenuse is 1. Is everyone following along, or am I just going blah, blah, blah? I'm just going blah, blah, blah. Okay. I know we're tired, guys, but we can still do this. All right, here we go. So I'm going to write 2n equals 1. So my short leg, n, has to equal a half. So my short leg is whatever's opposite 30 degrees, so it's this vertical displacement. That's a half. Are we okay? All right. My long leg says half times square root of 3. So n squared root of 3 equals half times square root of 3. Now, you could leave it like this, but write it like this as a nice little fraction. Square root of 3 over 2. That is my horizontal displacement, so it's this distance. Square root of 3 over 2. Are we still okay? All right, so that means on this triangle, this horizontal distance to get this coordinate, that's a horizontal displacement. This x coordinate has to be what? You can say it, be proud. And if you make a mistake, no big deal. Oh, come on, guys. What do you think that x coordinate is? It's the same triangle. Yeah, square root of 3 over 2. Square root of 3 over 2. That's where it came from. It came from that right triangle. What is the vertical displacement? Yeah, what is vertical displacement is like, what is this distance here? Yeah, 1/2. So that means this is 1/2, and that's a y value, so that's a half. See? Cool or not cool? There's another 30, 60, 90 triangle. It's this one right here in burnt orange. Hold on. I don't think it's the real one. All right, guys, sorry about that little hiccup there. So, do you see that burnt orange triangle here? That burnt orange triangle, all right, guys, focus. That burnt orange triangle is another 30, 60, 90 triangle, guys. But the 30 degrees is up here this time, and this is a 60 degrees. So, all that means is that instead of being the square root of 3 over 2 comma half, what do you think the coordinate's going to be now? Yep, half comma square root of 3 over 2. Let it go to voicemail. There's no voicemail. Hey, what's going on, Miss Corpus? Who's leaving today? Who do you think is okay? No, it wasn't for Leah Pena. It was for you, miss. All right, 45, 45, 90 triangle. It's right here in sky blue, I guess. And I'm just gonna draw it here because it doesn't fit anywhere. So I'm gonna draw it. I'm gonna draw it in the intentionally left blank. Perfect. I got a lot of space back then. So here's my 45, 45, 90 triangle. Let me make it big. (45 degrees, 45 degrees). Remember that the radius is 1. So I want, let's see, what do I want? In a 45, 45, 90 triangle, the relationship is n square root of 2. And I already know that the hypotenuse is 1. So I'm going to write n square root of 2 equals 1. And then to get n by itself, you just divide by square root of 2. So 1 over square root of 2. Now, you could leave it like that, and that is correct, that it is 1 over square root of 2. But usually they do something called rationalizing the denominator, as you guys have heard, because you guys did a whole bunch of delta. And it's saying, write it in, rationalize the denominator. Do you guys remember that? So we got to multiply this by 1, which is square root of 2. Later, miss. Have a good one. Multiply that by square root of 2 over square root of 2. So when you do that, you're going to get square root of 2 over 2. So both of these legs are square root of 2 over 2, square root of 2 over 2. So then I come back, and I'm going to write square root of 2 over 2 right there. See? How are we feeling? We feeling okay? What's up, Jack? Yeah. Let's scroll more. All right, here we go, guys. We have a few more blanks. Where, what do you think goes in here? I heard someone say it. What? The radians, guys. 0 radians, pi over 2 radians. You got to know those, right? 0 pi over 2. Now, at 30 degrees, remember, how do you convert 30 degrees into radians? 30 degrees multiplied by pi over 180. 3 goes into 18 6 times, so that's just pi over 6. So I'm going to use this dashed line to be my fraction part, my divisor, pi over 6. 45 degrees, how do I get 45 degrees to be a radian? Multiplied by pi over 180. I know that 45 plus 45 is 90, so that's 45 times 2. So 45 times 4 must be 180, so this must be pi over 4. Pi over 4. And then finally at 60 degrees times pi over 180. I know that 6 goes into 18 3 times. So pi over 3. And then you got to know the pi over 2 one. How do you feel? I know it was really warm outside, but are we kind of cooling off a little bit? No, not even close. Okay. Tell me where I lost you. Or you're just not cooling off? You're just answering the question. But we're okay with this, right? Or no? Kind of? Okay. Don't worry, we're gonna talk about it more, miss. Okay. Here we go. Let's go to the next page. Well, not the look at that, the last page, I guess. Don't cry. Don't cry. We're gonna get it nice and organized. Look how nice it's gonna be. Let's fill in what we know. So let's first do the degrees. So here we go. I'm going to start at the degrees. 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. And you just continue with that pattern. So what's the next one? 120. What's the next one? 135. What's the next one? 150. What's the next one on the way? 180. What's the next one? 210. 225. 240. 270. What's the next one? 300. Then what's the next one, guys? 315. Then what? 330, and then finally you've done a whole revolution, which is 360. So we at least got that down. That's good. Then let's see if we can do the radians. 0 radians. So let's do the easy ones that we know. 0, pi over 2, pi, and 2 pi. Oh, and well, down here, 3 pi over 2. So you should know those. And then a little while ago, we did quadrant 1. And we figured out that 30 degrees was the same thing as pi over what? 6. Well, what about 45 degrees? Pi over 4 and pi over 3. So know the quadrant 1. You got to know quadrant 1. What about quadrant 2? Well, you could, if you wanted to, I'm just going to do 1. You could go 120 times pi over 180 and do that for all of them. 6 goes into 12 twice, so 2 pi over 3. 6 goes into 12 twice. 6 goes into 18 3 times, so 2 pi over 3. And then I could put 2 pi over 3. You could do that for all of them if you want. Put your pencils down, because we're going to talk about a hack. So let's do a hack. That's going to be way easier than doing this for every single one. So don't write this down, just listen. This reference angle right here, let's see if we can figure this out. That's pi over 6. I know that because it says pi over 6 here. So that means this guy, this distance here, must also be pi over 6. Yes or no? This gap here must also be pi over 6. And this gap here must also be pi over 6. Do you guys agree? Okay. Then use your mental energy. If this is pi over 6 and it's only pi over 6 away from pi, What do you think this guy is that when I add pi over 6 gets me to pi? Yeah, someone say it. What is it? Say it. 5 pi over 6. Yeah. It must be, guys. It must be 5 pi over 6 because pi over 6 plus 5 pi over 6 will get you 6 pi over 6, which is just pi. Does that make sense? That's how we got the 2 pi over 3. This right here, this distance that I'm putting in sky blue, that's pi over 3. So 2 pi over 3 plus pi over 3 gives you pi, or 3 pi over 3. Okay, now you can write. Does that make sense, guys? So take a guess. What do you think it is at 135 degrees? Keep the denominator. It's still a 4. So a 4 in the bottom. What do you think on the top? Say it. It's okay if we're wrong. 3 pi. There it is. We got quadrant 2. All right, look at quadrant 3. I'm still looking at the pi over 6 one. This is pi over 6, this reference angle. So pi plus pi over 6, just give the denominator of 6 to the pi. So how do I do that? Just put a 6 and a 6. Look, 6 pi over 6 is pi. And add pi over 6, what's that? 7 pi. So this is 7 pi over 6. What's the next one? The denominator stays the same, 4. Did you say 5? 5 pi over 6. Sorry. 5 pi over 4, sorry. And then the next one at 240, the denominator stays as 3. What do you think is the numerator? 4 pi over 3. And then 3 pi over 2, you just got to know that one. Okay, again, I'm starting at the pi over 6, so I'm looking at this reference angle right here. I'm pi over 6 away from completing 2 pi. So 2 pi is the same thing as saying 12 pi over 6. So if I'm pi over 6 away, what do you think this one is at 330? 11 pi over 6. Keep the denominator the same. The denominator was a 4, so what do you think this one is? 7 pi. Keep the denominator the same, 3. What do you think this one is? 4 pi. 3, 6, 5 pi. Man, sorry guys, it's been a long day. 5 pi. I heard someone say 4, or maybe I just heard it. Third thing, and no one said 4, and I just wrote 4. All right. You can always multiply. You can always take the degree and multiply by pi over 180 to get these numbers. You can always do it. Now, I want to make sure, because you guys are really good at memorizing stuff. You guys are really good at just taking it all in. But then they ask, because you data dump, right? So you take it all in for the exam, and then a week later you don't know it because you just, as soon as after the exam you're like, oh, I'm done. All right. Work smarter. I was about to say work harder. Work smarter, not harder. It's been a long day, so if I get my words mixed up. Look, there's patterns here. It's so easy to just memorize patterns. That is simple to memorize. You don't have to memorize it. You can just, but look how easy it is to memorize. You got to know quadrant 1. No quadrant 1 for the radians. What did you observe? If that was 1/6 pi, we observed that was 5 pi 6, 3 pi 4, 2 pi 3, respectively. All you gotta know is you gotta keep the denominators, be consistent, it's symmetric, and it's one integer less. Look, if that's a 6, 5 pi. If that's a 4, 3 pi. If that's a 3, 2 pi. That's the relationship in quadrant 2. In quadrant 3, 1 more. The integer, the numerator, is 1 more than the denominator. That's a 6, so a 7. That's a 4, so a 5. That's a 3, that's a 4. What about quadrant 4, Chavez? I don't see a relation for quadrant 4. There is a relation for quadrant 4. Double the denominator, keep the denominator the same, 3, 4, 6. Double the denominator, subtract 1. Double of 6 is 12, subtract 1, 11. Double 4 is 8, subtract 1, 7. Double 3 is 6, subtract 1, 5. And there it is, guys. Do you see the relationship? 1 less, 1 more, double, subtract 1. Or you can just, just do it as a reference. Or just multiply by pi over 180. Look at all the different ways you can solve it. Is this making sense, guys? All right, write these notes down however you want to write them on your little paper. You okay? If you want to take a break and get up for a little bit, you can. Maybe if we do punches, we'll wake up. Have you guys ever practiced, have you ever done your forms in karate? Have you been in karate before? Oh yeah! Like, do you know what I'm talking about? Yeah, if you ever in Taekwondo, you do 4. Start like that. Yeah. See? So, I got all the way to yellow belt, which is the second belt. I only know like 6 forms. But I used to be pretty good. Okay, don't make fun of me. All right, here we go. You guys ready? The coordinates. The coordinates are the simplest. You already know quadrant 1, no quadrant 1. Let's fill on the easiest coordinates to fill in is the coordinates that like these at the x and these 1 0 0 1 negative 1 0 0 negative 1 and there it is because the radius is 1. And then no quadrant 1. So in quadrant 1, the x coordinate at 30 degrees, square root of 3 over 2 and a half. That's a y coordinate. At 45 degrees, what do we get? Square root of 2 over 2, square root of 2 over 2. At the 60 degrees, take the 30 degrees and just switch it. So 1/2, square root of 3 over 2. So you got to know quadrant 1. So there it is, no quadrant 1. In quadrant 2, the x turns negative, the y stays positive. So just reflect it, make the x negative. So that means that the 120 degrees, or the 2 pi over 3, make the x negative half, and the y stays as positive, square root of 3 over 2. At the 135, negative square root of 2 over 2, square root of 2 over 2. At the 5 pi over 6, or the 150, negative square root of 3 over 2, 1/2. Yay or nay? In quadrant 3, they're both what? They're both, starts with the letter N. They're both negative. Just reflect it. Negative square root of 3 over 2, negative 1/2. Negative square root of 2 over 2, negative square root of 2 over 2. Negative 1/2, negative square root of 3 over 2. In quadrant 4, which one's positive, which one's negative? X is positive, y's are negative, so at the 300, you put 1/2, negative square root of 3 over 2. All I'm doing is reflecting the coordinates, guys. Square root of 2 over 2, negative square root of 2 over 2. 1/2, negative square root of 3 over 2. Oh, the other way around. It's been a long day. Square root of 3 over 2, square root of 3 over 2, and then negative 1/2. Sorry about that. I'm glad I caught it fast enough. Sometimes when I'm really tired, I won't catch them. Okay, how do we feel? Nothing crazy, right? I hope I haven't confused you too much. I hope I haven't made, have I made a lot of mistakes on today's? Like a lot, like so many mistakes that I can't use this video? Or did I find them all and correct them and so we're good? Okay, so I'll upload this video even with the fire drill and all, we'll put it up. Okay. Look at this beautiful unit circle that you just created. Did you know about the unit circle before today? Maybe someone just made you memorize it and you had no idea where it came from. We derived everything from scratch, guys. There's not a single thing that I told you like that we didn't. Like every single element we got from scratch. We got we got the angles from scratch, we got the radians from scratch, and we got the coordinates from scratch. Everything. So look, no, I mean, yes, we're gonna remember it or memorize it, quote unquote, but we know how to get every single coordinate and every single radian from scratch, right? So we're not robots, correct? So aren't you happy? Look, like, okay, here's what I want you guys to do. Maybe I'll give you extra points. Maybe. I want you to show this to your guardians or to your adults or whoever it is that you live with, your grandparents, guardians, grandma, grandpa, dad, mom, whoever, brother, sister, as long as it's someone older that looks over you. Show it to them and have them email me that they saw this, that you talked, and not only, I just don't want you to say, Mom, just email my teacher. He's gonna give me extra points. Email him. Just email him. Because I know some of you. Yeah, I know some of you. That's exactly what you would do. Mom, just email my teacher. Look, put the unit circle, word the unit circle, and email him, and he's gonna give you points. Just do it, please. No, show them this, and then just try to have a conversation. Like, oh, let me talk to you about the unit circle. Like, you see these angles? Like, they're special angles. They come from the right triangle, and these are called radians. They're the same as measuring for degrees, but it's just a different unit, like centimeters and inches. It's the same. It's a way to measure rotation. And these coordinates, we got them from the right triangle, special right triangle, 36 and 90, 45, 45, 90. Remember that class that I took in geometry my freshman year? I thought I was never going to use it. Well, I used it again right here in this class. So, yeah, I am using the stuff that I learned in geometry. have an actual conversation with your adults, and if they email me, I'll add points to your exam. And your exam's coming up soon, by the way, so I don't have a definitive date yet, but I'll let you know at least a week before. So I guess it's not going to happen next week because it's going to be... Okay, put in your calendars. We better have an exam. Not this coming Monday or next Monday we have off, huh? Okay, well, it doesn't matter. Tuesday or Wednesday. Next Tuesday or Wednesday, I think Memorial Week or whatever. When we come back, we'll have a test. So Tuesday will be B day, and then Wednesday will be A day. So you guys will test Wednesday of next week.
Next week or after?
After... Let me look at my calendar.
After the Monday.
So we will test. You guys will test the 6th. Yes, everything that we've been learning. All right. No, not that. That's gonna be a different way. You'll see what I mean. Because I'm not gonna grade it like super hard, like the way you'll see what I'm talking about. All right. Now there is an activity for this, but I don't think we have enough experience yet. So here's what I told first period. So I'm going to tell you guys the same thing. There's a UH quiz, and it's called Right Triangles and Sectors. And I'm sorry that I'm writing really bad. Also, this thing's lagging really bad. It's called Right Triangles and Sectors. All right, guys, focus for a little bit. So the website is estudy.uh.edu. Now, there's going to be a few of you that are going to have hiccups because you couldn't remember your password. Tell your laptop to remember your password, guys. That's why we have technology. So tell your laptop to remember your password so you don't have to remember it. Go ahead and make an attempt. I want to see everyone have an attempt today. It's okay if you get a bad grade. It's okay if you get a bad grade. Okay, so let me tell you about this in case I didn't get to tell you last time, which I think I did, but I'll just reiterate it again. You can always ask me questions while you're live on Delta Math, because Delta Math is best practice. So if you ever have questions on Delta Math, bother me for whatever question you have while you're live. But on the UH quizzes, if you're live, don't ask me for help because then I'd be giving you the answer. You know what I mean? So, like, take it, see what grade you get, and then there's a way that you can see it. Look at the magnifying glass and click on it, and you can see the questions you missed. Does that make sense? And then show it to me or print it out, whatever you prefer, and say, child, how do I do these? We can do all the questions if you want, because I've done that before with you guys that say, you know what? Because I've seen it before where I tell like where someone logs in, I don't know how to do any of it, and all they do is push whatever for 10 seconds. And like, okay, child, I did it in 10 seconds. Go ahead and go over all these questions for me, please. And then we go over them. If you want to do that, that's fine. You're cheating the system, but that's fine. I'm not gonna get that. So here's what I ask. When you do your attempt, just make an honest attempt, see what you can, but don't worry about the grade. I know everyone's very motivated. You have a week. This is going to be due. Did I put the due date up there? Okay. It's attempted today. Put it on your calendar. It's due next week. So with a week, is that enough time for you to get your 100? Because I know everyone wants 100. Yes. I have tutoring every day next week except for Fridays. I have tutoring every day except Fridays. Monday, Tuesday, Wednesday, Thursday. I've only been seeing one of you consistently, and it's from first period. I've only been seeing one of you consistently from first period. I haven't seen any other pre-cal students other than that one kid. She comes every day to work on pre-cal. So besides her, I haven't seen anyone else consistent. I've seen some of you here and there come in, but not consistently where you're coming in like all the time. So I'll be here all next week. Let's make an honest attempt, guys. You can talk to each other. You can help each other. That's fine. I just can't help you while you're live. Does that make sense? All right, guys. So that's it. Let's log in. And if you have any login issues, let me know.